today we will conclude section 2.8, which will actually put a bookend on the chapters. We are finishing up that chapter right now. Section 2.8, part B, I guess you could say. We're still solving rational functions and or other kinds of ridiculous functions, but now they're inequalities instead of equalities. The process is still going to be the same. We're trying to track down zeros, and we're trying to track down inequality. What's the word? Not. No. The discontinuities. That's the word I'm looking for. So we're trying to track down zeros and discontinuities. We build sign diagrams, and we go from there. Yay, Kristen. Cool. So that's what we are going to do. Here we have a rational expression, 5 over x plus 3 over x minus 1. Now, if this was an equality, then I would be solving this the way that I showed you back when we were solving rational equations. I would just be distributing the least common denominator across everything. That process can still work. You just have to remember that this is a rational inequality, which means as it stands right now, there are 2 vertical asymptotes. Okay? X can't be -3, x can't be +1. So we have an option. We can either solve it the same way that I did before, but first thing we would have to do is write down those 2 discontinuities, and then we can go from there. Or we could try to combine these 2 fractions into a single fraction, and then we'd easily be able to see what makes the top equal 0, what makes the bottom equal 0. Which do you prefer? Combining? Okay. Well, a couple people said combining first, so I'll just go ahead and combine them first. I think that's what's in my notes anyway. The first fraction does not have an x minus 1 in its denominator. So in order to make these things match, I'm going to have to stick an x minus 1 down there. If you multiply the bottom by x minus 1, though, you are going to have to multiply the top by x minus 1. And then plus. And same logic. The second fraction does not have an x plus 3 in its denominator, and it needs one. So we'll go ahead and put one down there. There was already an x minus 1 there. And we are going to throw an x plus 3 down there with it. But whatever you do to the bottom, you must do to the top. And we've done absolutely nothing on that side. So still less than 0. Now what you're going to have to do on the top is you're going to have to distribute and combine like terms. So when you write it as one fraction, you have 5x times x minus 1 plus 3 times x plus 3 all on top of x plus 3 times x minus 1. Do not FOIL out on the bottom. You want to keep everything factored because that shows you that your discontinuities are still going to happen at -3 and +1. So leave everything factored. I mean, that's what we were doing when we were solving the rational equations anyway. The very first thing we do is factor everything, right? So let's leave it factored. See on top, we have 5x minus 5 plus 3x plus 9. Running low on vertical space here. Let's see, like terms on top. Going to give me 8x plus 4. Everything's still good? Not moving too fast? Now the top does factor. It has a GCF. 4 comes out. It doesn't really matter if you pull that or not, but you might as well be in the habit of factoring everything that you can factor. So let's pull that. There. Now we can see our 3 critical values. The 2 that make the bottom equal 0 will be discontinuities. They should be vertical asymptotes. And the 1 that makes the top equal 0, and that'll be a 0. So our sign. Yes. What's the question?
If at the very beginning I multiplied everything by x plus 3 times x minus 3 times the entire equation.
You mean x plus 3 times x minus 1?
Yes.
Yeah, so if you use my solving method, where I just distribute the LCD across everything, you will still get the same answers. You just have to remember that At the very beginning of the question, there was two fractions, and they both had a number x was not allowed to equal. So if you use my other method, all your fractions disappear. So it's just important that you keep track of your discontinuities from the very beginning, and at the end, those two discontinuities still need to be on your sign diagram. But yes, it'll still work just fine. It'll work exactly the same way. Okay, let's see. The top is going to be 0 at -1/2. So three critical values, one at -3, one at -1/2, and one at +1. And of course, the two at -3 and +1 are discontinuities. So we put our little red dotted lines like that. And we have 4 zones to check. We are specifically looking for the ones that are negative because we are less than 0. All right, so a number to the left of -3, like -4. On the top, that's going to give me a negative number. On the bottom, it's going to give me 2 negative numbers. 3 negative numbers results in negative result. That's a weird thing to say, results in a negative result. Ends up as a negative. Yes, but because there are 3 negatives, see the 2 negatives on the bottom create a positive. So I actually have a negative number divided by a positive number. Let's see, -2. So we plug in -2. On the top, we are going to get a negative. But on the bottom, I'm going to get a positive and a negative. So since I have an even number of negative signs, this gives me a positive result. My curve would be above the x-axis in that region. My favorite one to plug in, 0. Top is positive, and on the bottom I have a positive and a negative. Since there's a single negative sign, negative, and see a number like 2, all positives. And our solutions are where the thing is negative because, less than 0. So our solution set begins at -infinity, if you could think of that as an actual beginning. Comes all the way up to -3, cannot include -3 because that is a discontinuity. And then from -1/2, can't include it because it says strictly less than. If it said or equal to, that -1/2 would have had a bracket. Like that. Ta-da! Yes?
So is everywhere where it crosses the axis discontinuity?
No, everywhere it crosses the x-axis is a 0.
So why is it discontinuity?
Well, your sign diagram needs to have discontinuities and zeros on it. Because if you have let's say we have a discontinuity. Let's say I ignored the number -3. Then I could have said, oh, this thing was negative. Let's say, for example, pretend this was a minus sign. It's not. Just pretend it was. And you didn't have that discontinuity there. Then your first set would have said from -infinity all the way up to -1/2, implying it was negative at x equals -3. But it's not negative at x equals -3 because it doesn't exist at x equals -3. So the sign diagrams have to include the zeros and the discontinuities just in case you accidentally were to say, oh, my graph was negative there. No, that doesn't make any sense if it doesn't exist there. Okay?
So are the two discontinuities
Shouldn't it also
-3?
have
Hold on. 2 people. Kai, what's up?
The two discontinuities are -3.
Yes, because they make the bottom equal 0. The bottom's not allowed to use zeros.
Is it just coincidence that if you put those in the x's in where the x's equals 0, or is it what?
Is it just coincidence if you put the
If you put the -3 in, you get a -3. -3 plus 3 is 0.
right? But that's the whole point. You can't have a 0 on the bottom
Oh, okay.
because you can't divide by 0. That's what makes it discontinuity. McKinley, what's up?
after lunch, will it also be in 1 to positive infinity?
Well, we're looking for places where it's negative.
Oh, okay. I'm good now.
Okay. This one's kind of fun. Got a binomial being multiplied to a square root graph. Well, let's see. We should be able to easily see its zeros, right? You can pretend it's a factored polynomial. It looks like 2 zeros to me. It's going to have a 0 when x equals 3 and when x equals -1. Now, this doesn't have any vertical asymptotes, right? Because it's not being, you can never divide by 0 here. There's no division going on. But that doesn't mean that it has domain of all real numbers, right? We got a square root here. And that square root is going to kind of boss around our domain, isn't it? What kind of numbers can I not take the square root of in the real number system? Negatives. So what does that tell us about the domain of our function? Greater than or equal to -1. And the reason why we're allowed to include -1 is because you could take the square root of 0. It's 0. So what does this mean for our sign diagram? What it means is it doesn't have an arrow on both ends. Our function literally has a beginning. So our sign diagram will represent that by just having a straight up and down line at x equals -1. This is our sign diagram. There it is. So no discontinuities on this one. Only 2 regions. And we just need to figure out which one is positive. And since we have an equal to bar, we're going to have a bracket in our solution. If you plug in the number 0, you get a negative number times a positive number, giving us a negative result. We don't want that. And if you plug in a 4, you get a positive times a positive. So we have our answer is going to be to the right of 3 and including 3. Look how easy that one was. And the reason why we're including 3 on this one is because this is greater than or equal to 0. That equal to bar gives us that bracket. Now I have no idea what that graph looks like, but I don't care. Yes, sir. I'm sorry? Ooh, good for you. Yeah, you see, -1 is part of the solution set because it's equal to 0 there. Yeah, good. Yeah. So I can't remember if I just wrote x equals 1, -1. Oh, no, okay. I included it as a set. Like this. Because this is called a solution set. And when you have to list a single number, you just put braces around it. That means the set of x's, -1. Oh, and also everything from 3 to infinity. That's what that says. Bless you. Bless you. The -1 is representing another place where the graph is equal to 0. Because of the equal to bar, that's part of our solution set. If it was strictly greater than, you would not include the -1. And you also wouldn't include the 3 either. It'd be a parenthesis, not a bracket. Is that a question or a stretch? It was a stretch. Okay. We good? I thought I had you. Well, I think I had most of you. Oh, look at this one. We have an absolute value expression in the bottom of a fraction. Okay, yeah, Max has noticed that x can't be -3. That means we have an infinite discontinuity, x equals -3. And the other critical value would be where the top equals 0, which is a 0. So where do we have a 0? At x equals 2. Simple sign diagram. Oh, goodness. That 2 has seen better days. Let's try again. Simple sign diagram, only 2 things on it. And this time I do have a sign diagram that points in both directions forever because I don't have any square root bars. We have -3 and +2. But x equals -3. Like that. All right. We are looking for where it is less than or equal to 0. So brackets. Let's check a number to the left of -3, like -4. Hey, you know what's really cool? The bottom, always positive or 0. course, it can't be 0 because we put an infinite discontinuity on there, so the bottom's always positive. So it really doesn't matter what's going to happen on the bottom. Absolute value bars dictated positive number down there. Makes life good. That means that the sign of this thing is determined by the top. Whatever sign the top has, that's the sign of the whole function. So let's see. If we plug in a -4 on top, ooh, negative number. If you plug in a 0 on top, ooh, still negative number. And then anything bigger than 2, like 3, positive. So the signs for this object are negative, negative, positive. And we were specifically looking for where it was less than or equal to 0. So now we want where it's negative. Yep. Our solution set begins, if you could think of it as saying it begins there, out at negative infinity, coming all the way up to -3. And Kai, this is a perfect answer to your question. You see how it's got the same symbol on both sides of that discontinuity? I can't include it though because my graph doesn't exist there. So that's why we have to have the discontinuities on the sign diagram. There would be a bracket on the 2 because it says or equal to. Well, that's an infinite discontinuity because it's where you're dividing by 0. So you do have a vertical asymptote there.
So it's gonna be like 2.
If I had to sketch the graph based on this sign diagram, it looks like it would be like that, and then something like that. I mean, I'm guessing, complete guess, but that is a possible shape for it. But that's it. Yeah, see, I almost could have gotten all these into one period on Friday, but that was it. Any questions on those, or are we good? Everything's good? Awesome. Cool.
You don't include anything after 2.
Why don't I include anything after 2? Because after 2, the function is positive, and we were specifically looking for where it was negative.
Okay.
Okay?